Walk through a public park on a quiet afternoon, or step into your own backyard garden. What do you see? You see a world of passive beauty. You feel the gentle rustle of leaves in the breeze. You might touch the soft, yielding texture of a petal, or admire the stoic, silent presence of a tree that has stood for decades. We have come to see the plant kingdom as a gentle, giving, and fundamentally defenseless part of our world, a beautiful, green backdrop for the more dramatic lives of animals. They are the producers, the scenery, the victims. But imagine, for a moment, that this tranquility is a modern invention, a fragile peace treaty signed only after eons of brutal warfare. What if the silent greenery around you operated by the ruthless survival codes of its ancient ancestors from a time hundreds of millions of years ago? The truth is, the primordial world was anything but a peaceful garden. For the vast majority of Earth's history, the green world was not a sanctuary, it was a battlefield. The story of prehistoric plant life is not one of quiet, passive growth. It is a sprawling epic of chemical warfare, of intricate mechanical traps, and of a silent, brutal evolutionary arms race waged against titanic beasts. Before flowers even existed, plants had already developed arsenals that would make a modern military strategist proud. They were not simply waiting to be eaten, they were fighting back. This is the story we will uncover. We will peel back the layers of time to an era when the planet was dominated by giant ferns, colossal horsetails, and strange, alien-looking cycads. We will explore a world where a simple leaf could harbor a potent neurotoxin, where a branch could be studded with razor-sharp armor, and where a seemingly harmless plant could be part of a grand strategy of attrition designed to wear down and defeat its enemies over generations. Forget the tranquil garden. We are about to enter a world forged in poison and deadly traps, a world where plants were anything but defenseless. To understand why a simple fern or tree would need to become a fortress of deadly defenses, we must first journey back to the world it inhabited. Picture the Earth during the Paleozoic and Mesozoic era periods like the Carboniferous, the Permian, and the Jurassic, spanning from roughly 360 to 145 million years ago. This was a time of planetary transformation. The continents were drifting into unfamiliar arrangements, and the climate was often warmer and wetter than today. Under these conditions, plant life exploded. Vast, swampy forests blanketed the land, dominated not by the familiar oaks and maples of our time, but by towering lycopod trees, gigantic horsetails that reached for the canopy, and sprawling jungles of ferns. This was the age when Earth's first great forest rose, creating the very coal and oil deposits that fuel our world today. For a time, these plants grew in relative peace, but evolution abhors a vacuum. This immense, untapped reservoir of energy global, all-you-can-eat buffet was destined to attract competitors. First came the insects and early arthropods, but the real pressure began with the rise of the first terrestrial herbivores. Small at first, these plant-eating reptiles and amphibians began to nibble at the edges of this green empire. Then came the giants. The Mesozoic era, the age of dinosaurs, brought forth herbivores on a scale the world has never seen since. Imagine a herd of sauropods, the long-necked titans like Brachiosaurus and Diplodocus moving through a forest. These were not delicate grazers. They were living, breathing engines of deforestation, weighing tens of tons, and needing to consume hundreds of pounds of plant matter every single day just to survive. They didn't just pluck a few leaves, they stripped entire branches, toppled trees, and cleared vast swaths of vegetation. This relentless, all-consuming pressure created a stark evolutionary ultimatum for the plant kingdom: adapt or be eaten into extinction. This is where the concept of co-evolution comes into play. It's a biological arms race. As herbivores evolved to become more efficient eating machines, plants were forced to evolve more effective defense mechanisms. In response, herbivores would then evolve ways to bypass those defenses, perhaps a more robust digestive system or teeth that could withstand tougher foliage. This cycle of adaptation and counter-adaptation, unfolding over millions of years, drove both plants and animals to incredible extremes. The immense size of a sauropod, for example, wasn't just for reaching high branches, it was likely also necessary to house a gigantic, complex gut, a living fermentation tank capable of breaking down the tough, fibrous, and increasingly toxic plants that made up its diet. Plants couldn't run, and they couldn't hide, so they had to fight. And they did so with a silent, invisible, and utterly devastating arsenal. The most sophisticated and widespread weapons in the prehistoric plant arsenal were not physical, but chemical. Unable to flee or fight with tooth and claw, plants turned their own bodies into chemical factories, brewing a dizzying array of toxic compounds designed to attack their enemies from the inside out. This was a silent, invisible war, waged on a molecular level. The battlefield was the herbivore's digestive tract, its nervous system, and its very cells. These chemical weapons fall into several major categories. One of the most potent groups are the alkaloids, a class of nitrogen-containing compounds that often have dramatic effects on animal nervous systems. Think of them as neurological scramblers. When ingested, they can interfere with neurotransmitters, blocking signals, causing uncontrollable spasms, inducing hallucinations, or bringing on complete paralysis. They are, in effect, a way for the plant to hijack the control system of the animal eating it. Another pervasive strategy involved tannins. These compounds don't necessarily kill, but they wage a war of attrition. Tannins bind to proteins, including the digestive enzymes in an animal's gut, making it incredibly difficult to extract nutrients from the leaves. They also create a profoundly bitter, astringent taste, that dry, puckering sensation you get from strong tea or unripe fruit. A forest full of high tannin plants was a forest full of empty calories, a place where an herbivore could eat all day and still risk starving. A third deadly trick was the use of glycosides. These were two-part chemical bombs. In their intact state within the plant cells, they were harmless. But when an animal chewed the leaf, it ruptured the cell walls, mixing the glycoside with an enzyme that was stored separately. This reaction would cleave the molecule, releasing a fast-acting poison, most famously cyanide, which shuts down cellular respiration in an instant. It was a booby-trap, set to go off at the very moment of attack. Perhaps no living plant better embodies this ancient chemical warfare than the cycad. These sturdy, palm-like plants are true, living fossils, a group that was already ancient when the dinosaurs roamed. They flourished in the Mesozoic, forming a major part of the herbivorous dinosaur diet, and they survived by being one of the most toxic plant lineages on Earth. Cycads are laced with a cocktail of poisons, but their signature weapon is a potent neurotoxin called cycacin. When eaten, cycacin is converted in the gut into an even more aggressive poison that causes severe gastrointestinal distress and, in the long term, liver and nervous system damage. But their strategy was even more insidious than that. Many cycads also contain another neurotoxin, BMAA, which can accumulate in the body over time, potentially leading to chronic neurological diseases akin to ALS or Parkinson's. This wasn't just about killing the individual dinosaur that ate it, it was a long-term strategy. A plant that sickened an animal, impaired its ability to reproduce, or caused debilitating illness in its offspring was waging a war against the entire species. The echoes of this ancient chemical conflict are all around us. The very compounds that plants evolved to deter predators have been co-opted by humanity. The powerful painkiller morphine is an alkaloid from the opium poppy. Quinine, the first effective treatment for malaria, comes from the bark of the cinchona tree. And on the other side of the coin, some of history's most notorious poisons, like strychnine and atropine, are simply plant-derived defense chemicals. The pharmacy and the poison cabinet are both stocked with the legacy of this prehistoric arms race. While chemical warfare was a plant's most subtle and sophisticated strategy, it was by no means its only one. When poisons weren't enough, the plant world turned to brutal, physical deterrents. This was the second front in the war against herbivores, a transformation of their very bodies into mechanical weapons and impenetrable fortresses. These defenses were overt, painful, and designed to make the simple act of taking a bite a miserable and damaging experience. The most obvious of these defenses are the ones that still vex gardeners and hikers today: spines, thorns, and prickles. These are simple but brutally effective. For a large dinosaur with a soft mouth and tongue, a mouthful of sharp, woody spines would be an immediate and painful deterrent. Fossil evidence is scarce, but it's highly likely that the ancient ancestors of modern roses, cacti, and acacias were already employing this strategy, but plants developed even more punishing armor. Many prehistoric leaves weren't soft and pliable, they were tough, leathery, and deliberately hard to chew. A key innovation in this physical war was the incorporation of abrasive minerals directly into the plant's tissues. The classic example is another living fossil, the horsetail. These strange, segmented plants, which in the Carboniferous period grew into 100-foot-tall trees, have a unique defensive trick. They draw silica, the same mineral that makes up sand and quartz from the soil, and embed it within their stems and leaves. Chewing on a horsetail is like chewing on sandpaper. For an herbivore, a diet rich in these plants would rapidly wear down its teeth, rendering it unable to eat and effectively sentencing it to starvation. This put immense evolutionary pressure back on the herbivores, leading to the development of ever more durable teeth, like the massive dental batteries of hadrosaurs, which had hundreds of teeth constantly growing and replacing the ones worn down by their abrasive diet. Beyond simple armor, we can speculate about more elaborate mechanical traps. While there is no fossil evidence of a carnivorous plant large enough to trap a dinosaur, the basic mechanisms for trapping prey existed. Imagine vast prehistoric swamps where early ancestors of pitcher plants evolved on a grander scale, their slippery, luring funnels potentially large enough to trap small reptiles or mammals. Picture trees that, like some modern pines, produced immense quantities of incredibly sticky resin, not just to seal wounds, but as a defensive goo that could ensnare the insects and small lizards that might try to climb them. The famous amber deposits that preserve these creatures are a testament to the effectiveness of this resin. While the idea of a man-eating plant is pure fiction, the concept of plants evolving passive, large-scale trapping mechanisms to deter or kill smaller pests is not. In a world of constant attack, any trait that gave a plant an edge, be it a thorn, a gritty leaf, or a sticky trap, was a weapon worth honing over millions of years. This physical arms race turned the primeval landscape into a hazardous obstacle course, a place where every branch could be a weapon and every leaf could be a shield. So we arrive back in the present, leaving the primeval swamps and titanic beasts behind. The world of prehistoric plants was no gentle, pastoral landscape. It was a laboratory of evolutionary warfare, a crucible where relentless pressure forced the Green Kingdom to innovate or perish. Out of this struggle, plants emerged not as passive victims, but as cunning strategists and resilient warriors. They filled their tissues with complex poisons capable of disrupting nerves and starving behemoths from within. They clad their bodies in razor-sharp armor and abrasive minerals designed to punish and wear down their attackers. This was a war fought silently, over millennia, on a global scale, and its outcomes shaped the very fabric of life on Earth. The legacy of this ancient conflict is not confined to the fossil record. It is written in the DNA of every plant alive today. The beautiful, fragrant flower in a garden may be a descendant of a lineage that first survived by producing bitter toxins. The towering tree in the forest stands on the shoulders of ancestors that learned to armor themselves against giant jaws. The chemical echoes of this war are now integral to our own lives. We harvest these ancient defense compounds for our own purposes, turning plant-made alkaloids into life-saving medicines and their tannins into industrial materials. We are, in many ways, the beneficiaries of a war we never fought, reaping the rewards of an arms race that raged for hundreds of millions of years. This brings us to a final, lingering thought. As we admire the seeming serenity of the natural world, a quiet forest, a field of wildflowers, a tranquil park, what are we truly witnessing? Is it genuine peace, a world that has finally found its equilibrium? Or is it merely a ceasefire, a temporary armistice in a biological conflict that has never truly concluded? The next time you walk among the trees, listen closely. Perhaps the rustle of the leaves is more than just the sound of the wind. Perhaps it is the whisper of a story, an epic tale of survival, of poison and armor, of a silent, ancient war that is still being waged, hidden in plain sight, in every leaf and every stem.